In this session, we look at graphing inequalities in two variables. For example, graph 2x plus 3y is less than 6. The first step in graphing an inequality like this is to graph the boundary. And the boundary is the line itself. That line is 2x plus 3y equal to 6. And remember how to graph a line. You make a table of values. And you can plot any points you want. The easiest ones to plot are the intercepts. So when x is equal to 0, you have 2 times 0 plus 3y is equal to 6. That tells you 3y is equal to 6, so y is equal to 2. And there's your y-intercept at 0, 2. And likewise, when y is equal to 0, you have 2x plus 3 times 0 is equal to 6. That tells you 2x is equal to 6, so x is equal to 3. And you have your x-intercept at 3, 0. Here's your coordinate system. Here's 0, 2, and here's 3, 0. And now we want to graph the line passing through those 2 points. But we have to decide whether the boundary, the line itself, is solid or dotted. And we look at the inequality itself. This is a strict inequality, so that corresponds to a dotted line. And what that dotted line means, the points along that dotted line are not part of the set. Graph a line passing through those 2 points, and that line is a dotted line. So that's step 1. Step 2 is to test a point not on boundary. The goal is to shade the true side, and we find out which side is true by testing a given point. Suppose we want to test the point 0, 0. Is 2 times 0 plus 3 times 0 less than 6? Is 0 less than 6? Yes. The side that 0, 0 is on is true, and so we shade the corresponding side. And here, true, and up here will be false. Let's look at a system of inequalities. Y minus x is less than or equal to 1, and y plus x is less than or equal to 3. Let's call this first one L1 and the second L2. Graph the boundary again. Take a look at L1. We make a table of values. When x is equal to 0, we have y would equal 1, and when y is equal to 0, x is negative 1. The coordinate system is 0, 1, and negative 1, 0. The inequality is inclusive, so that means it's going to be a solid line, L1. So the next step would be to figure out what side to shade. So let's test 0, 0, and is 0 minus 0 less than or equal to 1? Yes. Shade the side that 0, 0 is on. Next is to look at L2 is the boundary. It's y plus x equal to 3. Look at the table of values. When x is 0, y will equal 3, and y is 0, x is equal to 3. 0, 3, and 3, 0. And drawing the line passing through those 2 points. Next step is to shade the true side. Test again 0, 0. And is 0 plus 0 less than or equal to 3? Yes. Shade the side that 0, 0 is on, and we find out where the 2 sets overlap each other is the solution to the problem. Suppose we even put further restrictions on this and say x has to be greater than or equal to 0, and y has to be greater than or equal to 0. X greater than 0 is the right-hand side of the plane, and y greater than 0 is the upper half. We find where all of those intersections occur in the first quadrant, and from here, this is called a simplex, and we can do some linear programming would be the next step, and maximizing or minimizing some objective function. And it turns out those corner points are important in finding a maximum or a minimum, and that would be the next step in dealing with inequalities.